Okay, continuing with the multiple choice practice test. This is number 6. We have x squared plus xy is equal to 10. And when x is equal to 2, find the derivative at that point. So if we want to find the derivative, we have to do it implicitly because we have y within the equation. So that means when we come across y's derivative, we're going to have to involve dy dx. Also product rule, because we have x times y. We have two variables multiplied with one another, and if we want to find the derivative involving two terms multiplied together, we have to go through product rule. So here's my setup. X squared plus xy equals 10. I labeled the x and y as my f and g function. So we're going to find the derivative of each term here. X squared becomes 2x, and then I'm going to go through product rule for this. So f prime is 1 times g y plus f, which is the x function, times g prime. So y's derivative is 1 times dy dx, and the 10 goes to 0. Okay. Let's go ahead and solve for dy dx. 2x plus y plus x dy dx equals 0. Subtract the 2x and the y over, divide both sides by x. So now we have our slope formula, which is our dy dx. Now dy dx requires the x and the y value, and the problem only gives us the x value, so we have to kind of backtrack a little bit and figure out what the y value is. Well, if we know what the x value is for the equation, we can put it back into the original equation and figure out the y value at the order pair on this graph. So 2 plugs in for x, and we solve for y. So 4 plus 2y is equal to 10. 2y equals 6, and y equals 3. So there's my order pair, 2, 3. So we can plug 2, 3 back into the derivative equation, the derivative formula, and then in return, we're going to get the slope, the exact steepness of this point on this curve. All right, number 7. Definite integral of x squared minus 1 over x. Again, with definite integrals, we have to make sure we don't plug in the bounds at the beginning. This is the last step, not the first step. So we look at this problem here and say, okay, what can we do to get this ready for antiderivative rule? There's only one term in the denominator, so if I push this up to the top, make it x to the negative 1, and then distribute it through, I should be able to expand and treat it like two separate terms. So bring up the denominator. It ends up being a multiplication problem, so we add exponents to begin with. So x minus x to the negative 1, which is really x minus 1 over x. And we can apply the antiderivative rule for each term. The first term is using power rule. The second term is using natural log of x. So x becomes x squared over 2. And then 1 over x becomes natural log of x. Once we have the antiderivative, now we can work in the bounds. So upper bound gets plugged in first. We get e squared over 2 minus natural log of e, minus big parentheses, and then we plug in the lower bound. 1 plugs in for x, we get 1/2 minus natural log of 1. So we get e squared over 2 minus, now natural log of e is 1, minus 1/2 minus 0. E squared minus 1 minus 1/2 is the same thing as e squared over 2 minus 3/2. Answer choice E. All right, number 8. We have f and g being differentiable functions, which are the following properties, with the following properties. G of x is greater than 0, always a positive number, and f of 0 is equal to 1. So we have h of x is defined as f of x times g of x, and then they're telling us what the derivative is going to clean up to be. The derivative of this is going to clean up to be just f times g prime, and we know that there's something missing because we're expecting product rule with f of x times g of x. So what that means is if this is the cleaned up version, maybe something has disappeared or it just zeroed out. So let's see if we can piece together the gap. We have h of x equals f of x times g of x. If I go through the product rule at the beginning, I get f prime times g plus f g prime. but we're told that fg prime is the only thing that remains, and this f prime times g just completely goes away. So the only way that this is going to go away is if one of these terms is 0. We know it can't be g of x because g of x is greater than 0. So that means this f prime must be equal to 0. Right? F prime must be the one that's equal to 0. So if f prime is equal to 0, then f of x must then be a constant, because the only term that's going to result in the derivative of 0 is if it's like a constant, like a 2 or 3 or even a 1. And we're told that f of 0 is equal to 1. So this must be the constant, right? This must be the constant that produces a derivative of 0. So f of x must be equal to 1. Okay, number 9. We have a graph here that represents the barrels per hour. So let's read through this problem. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown. Of the following, which best approximates the total number of barrels of oil that passes through the pipeline each day? So we're trying to, essentially we're trying to approximate the region between the x-axis and the curve. So we're going to try to approximate this definite integral from 0 to 24 of b prime. Now we don't have the equation for this function, but a lot of this, the region kind of falls within something that we can have a relatively easy time approximating, because we have a bunch of rectangles here. So with each of these rectangle, the area is going to be width times height. So the width is 6, the height is 100. 6 times 100 is 600. So I know we see a gap here, but approximately this is 600. These are exactly 600. That's approximately 600. Now here we see a curve, and we're not going to be able to find the exact area, but if you look, this region kind of takes up half of each of these rectangles. So if we know the area of the rectangle is 600, and if we kind of approximately divide it by half, cut it in half, we get 300. So both of these regions is 300. We total all these values up. 4 times 600 plus 2 times 300. 2400 plus 600 is equal to 3000. Okay. All right, number 10. What is the instantaneous rate of change at x equals 2 for our function? So instantaneous rate of change just means that we want to find the derivative at 2. So 2 steps. Let's first find f prime. And to find f prime, notice that we have terms that are organized as numerator and over denominator. So we're going to go through quotient rule. So f prime times g minus f times g prime all over g squared. I'm going to clean up my derivative, distribute the 2x through, distribute the negative through, combine like terms, and we get x squared minus 2x plus 2 over x minus 1 squared. We now have our slope formula. We can now evaluate the derivative at 2. So plug 2 in for all the x's. We get 4 minus 4 plus 2, which is 2. 2 minus 1 squared, which is 1 squared, which is 1. So 2 over 1 is 2. Okay, number 11. F is a linear function. A falls between 0 and b. The definite integral from a to b of f double prime is equal to. So let's think about linear function. So linear function is going to be a function like y equals 3x plus 4, y equals 5x minus 6. I'm going to just leave it as y equals mx plus b. So if I want to find a second derivative function that I want to use, that means f prime is just going to be m, and that numeric value's derivative is just going to be 0. So essentially, it doesn't matter what my linear graph is, my second derivative is always going to be 0. So I'm trying to find the area of the region between the graph and 0. And we see that there is not going to be a region for us to find because this 0 lies exactly on the x-axis. So there is no region for us to find. There is no area. So the depth integral from a to b of 0 is just going to be 0. There's no area to compute, so our answer is just 0.